Okay, a student measures the count rate of a radioactive sample with time in a laboratory. The background count in the lab is 30 counts per second. And we have the following information here. What is the time at which the student measures a count rate of 45 counts per second? We are going to verify how the answer is indeed letter C according to the mark scheme. Alright, so first things first, we have information about the background count, which means that this value here in terms of our count rate is not what we're going to use as is. Okay, so what I need to do is I will subtract the count rate from the given the background count rather from the given count rate. So this is now going to be 120, and then the 90 is actually 60. Okay, furthermore, the question is also asking us what the time will be after a count rate of 45 counts, but because we have a background count of 30, that essentially is supposed to be 15 counts. Okay, so how do I handle this? How do I tackle this moving forward? One particular observation you must have is from 120 to 60. Notice that that is actually half already, half the original amount, okay, in a certain period of time, which is 20 seconds provided in the problem. You now have 60. So what does this mean? This means that this 20 here is the time it takes for half-life to take place. Okay, we are not subtracting 30 from the time. The time is just going to be as is. We are only subtracting it from the count rate, provided that we have a background rate or a background count. Okay, so now the formula for a problem like this, and this is not available in your data booklets, okay, but please take note, it's n over n naught equals 1/2 to the power of t over t to the 1/2. Okay, and you'll see what this formula means in a second. So this is the main formula that you will have to use in order to correctly solve this problem. Okay, so n here represents the 15 that we have from subtracting the background count to the count rate that the question wants, if that makes sense. So I'll write it first. So n is 15. Now your n naught is the original amount that you had. Okay, and in this case, subtracting the 30 once again from the original, that was 120. So notice how my numbers match. I used the 15 as a result of subtracting the 30 from this. Similarly, I'm using the 120 after I subtracted the 30 from the 150 originally. Okay, and then the 1/2 remains as is. Okay, the t value for t, I do not know that. As a matter of fact, the question is asking us what is the time. So there you go, that's your hint that you have to find the value for t. So what now will you put for t raised to 1/2? This value here actually just represents the time for half-life. And that is immediately evident in the given for this problem. That is 20 seconds. So I can just replace t to the 1/2 with 20. Okay, so please remember, t to the 1/2 just represents the time it takes for half-life to take place. And at this point, moving forward, we can just solve this, algebraically manipulate the problem. I could simplify and express 15 over 20 as 1 over 8. Okay, 1/2 raised to t over 20 stays the same. However, if you observe that 1 over 8 can actually be expressed as 1/2 quantity cubed, okay, that should still give me 1 over 8. And the reason I did that is just so that these values are the same, and hence I can set my exponents equal to each other. Okay, so this is going to be t over 20, which means that 20 should equal 60 seconds. And true to our answer, letter C is indeed 60 seconds. Okay, so you are allowed to use your calculator. So if for some reason you forgot how to do math, hopefully not, you could just enter this into your equation solver. I believe in your calculators you should be able to get the value for t. Okay, nevertheless, this is the process in order to solve a problem as such.